All right, so like I said, we need to finish one little problem in, or one type of problem, excuse me, in 2E, and then we are going to jump into 3A. If you have taken this class previously, you may remember that, or if you have somehow, you may have like an old copy of the notebook. We have removed section 2F from the content. And so, which was over the consumer price index, or CPI, which honestly I was really sad to do, because I think that it's a really appropriate view of how percentages and conversion sort of overlap. For those of you who are not aware of what the CPI is, the Consumer Price Index is a measurement of inflation. And so we used to do it, but honestly, students just sort of got it's too much of a niche application and then students would just get too caught up in the nitty-gritty conversion, and then they wouldn't end up seeing the forest through the trees. And so I decided that it wasn't really a very good use of our time anymore. So all of that to say is that if you have an old copy of the notebook for some reason, or you have taken this class prior, or you have talked to somebody, we're not doing section 2F. So if you had some awareness of 2F, we're not doing it. So we're finishing up 2E, and then we're going to go to 3A today. Okay. Let me look at our teaching calendar really quick to make sure I'm not. Yep, today's just solely focused on 3A. Next week we'll get into 3B and 3C. So all right, so 3A. Well, no, I lied. Finishing this percentages of percentages. So we're going to describe each of the following changes in two ways. An absolute change in terms of percentage points, and then a relative change in terms of the percentage. So I'm just going to do number 3 because it has the most space. This is the same application for all of the problems, but I'm just going to jump to 3. So it says the percentage of Americans accessing the internet increased from 67% in the year 2000 to 83% in the year 2012. So we want to first calculate what the change is in Americans accessing the internet in terms of percentage points. And all of that is just, it's just converting the two values, okay? So we're going to look at, so in 2000, it was 67%. And then in 2012, it was 83%. So obviously this is increased, right? If we think about the change in percentage points. So the absolute change we're going to take our new amount minus our original amount, and we can see that it changed by 16 percentage points. That doesn't mean it changed by 16%. That's just the increase in percentage points. We have to actually calculate the relative change in order to figure out what overall percent this increased by. So the relative change is really the more relevant thing here, okay? So remember, with relevant change, it's your new minus your original divided by your original times 100. So I want you to calculate that and send me your answer in a direct message, please. Okay, so we're going to do 83 minus 67, all divided by 67. And then I said, like I said, times 100. So make sure if you're plugging this all into Desmos, that you're following order of operations, right? Like we need to make sure that we're doing that subtraction first. So that subtraction is going to be 16. We already knew that from when we found the absolute change. And then we're going to have that divided by 67, then times 100. So when we do 16 divided by 67, we're going to get 0.2388 and a big long decimal. So then we multiply that by 100. It moves the decimal place 2 times, and we get 23.88%. And I didn't tell you how many decimal places to round to. So if you sent me 23.88, 23.9, or 24, I accepted all of those, okay? And so that means that the percent of Americans that were accessing the internet increased by 23.9% from 2000 to 2012. Okay, so again, the relative change, the amount of percentage points, isn't really informative. It doesn't tell us anything, but the absolute change, the number of percentage points, doesn't tell us. The relative change is where the information really is at. That's what gives us, an understanding of the situation. Okay. All right. So before I move forward to 3A, what questions do we have?
I'm good. I don't know about everybody else.
All right. So when we're switching gears, which can be kind of weird sometimes in terms of like trying to wrap our brains around what's happening. So like in some ways we're still processing unit 2, but in order to like keep with the flow, we have to switch to unit 3. So unit 3 is a very short unit. It's only 4 sections, 3A, 3B, 3C, 3D. And unit 3 is our probability unit. We just touch on probability a little bit. And then when you go on to your next class after this, that will be expanded upon. So in order to be able to discuss probability, we have to be able to discuss sets. And in order to understand sets, we need to understand set notation. So this first box you see here on 3A, it's a lot of information, okay? So I'm gonna sort of slowly go through it and pop back up to the information. There is a lot of, what is this? What would I call this? Notation, right? There's a lot of new symbols that you might not recognize. So just go slow with it. And it's going to take a little while to get accustomed to it, okay? So the first thing we look at here in this box is the definition of a set. What is a set? A set is a well-defined collection of objects. So when you're describing a set, you want to define it, well-defined it, right? So if I were to describe, if I were to try to describe our class, I would be like, oh, well, they're Math 94 students. Well, that's not a very good description in terms of our specific class, right? If I wanted to talk about our specific class, I would have to say students enrolled in Math 94 section 2 or section 60, right? Because that's what our class is. Those are the students. That is a better definition of who we are. And so when we're defining them, we want to make sure we're coming up with a good definition, a well-defined definition, okay? So when we talk about sets, the things that are in the set are called elements, right? And so these are also called objects. And then you'll notice that we have this notation here, which kind of looks like an E, right? Which helps me remember elements, right? But you'll notice it's kind of like a C with a line through it. So that is your symbol for element. So elements are objects or members of the set. You'll notice if we take that symbol and we put a line through it, that is the that indicates that it's not that. It negates that. So what that means is that it's not an element versus being an element. Okay. And elements are usually denoted by lowercase letters. Well, the sets themselves are usually denoted by uppercase letters. So the elements of the set can be displayed by listing all of them between braces or brackets. We use curly brackets. And I know that these are difficult to draw. And I will be honest with you, after a while, mine just start to look like this. But again, we do our best, right? So you don't want to use parentheses though. You do want to use the curly brackets. So what we have listed here, this first set is set A, and it contains the elements A, B, and C, versus set B contains the elements A, B, C, all the way down to Z. Okay, so that notation B equals, and then A, B, C, dot, 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 down to Z. The dot, dot, dot is indicating that the pattern we are recognizing in between here, meaning the letters of the alphabet, that continues to the letter Z. This is referred to as roster notation, and we can also use set builder notation to avoid listing every element in the set. And so set notation, or excuse me, set builder notation is a different way to describe a set. So what you'll see here in this statement here, this is referring to this set right here. So set B, it contains the letters of the alphabet from A to Z. And the way that we would describe that is B is equal to the set X such that X is an element, oh, excuse me, X is a letter of the English alphabet. So again, it reads B is a set of elements X such that, there should be a comma here, such that X is a letter of the English alphabet. This little thing right there, that vertical line is the such that. So the farther you get into mathematics, the more the textbooks look like just full-on words. Like there's very little solving and equations and things like that. It gets more into proofs and stuff. And for somebody who struggled with writing, that was really hard for me when I made the transition. And so I understand that this feels very weird. You're like, wait a minute, this is not the math that I'm used to doing. But again, we need to be able to describe these in order to get to the point of where we start to find probabilities of sets. Okay, so that vertical line is the notation for the phrase such that. And then from there, we've got this notation here, N of A, is the notation that indicates the number of elements in a finite set A. So for example, if I said that A is equal to the numbers 1, 2, 3, 4, and 5, right? That's the set A. When I said N of A, I'm saying how many elements are in that set. Well, there are 5 numbers in that set. So N of A, the number of elements in A, is equal to 5. Then we have the concept of the empty set, which is a set with no elements in it. This set is a subset of all sets. An additional notation includes the term null set, a 0 with a line through it, or just brackets without anything in it. Okay. Don't use that. That is not the same thing. So don't take your brackets and then put the 0 with a line through it. That doesn't mean the null set. That is it's gibberish, I guess, for lack of a better way to put it. It doesn't mean anything. That's not appropriate notation for representing the empty or null set. Okay. So before we go forward again, there's a lot of stuff. Questions about what I've said so far? Okay. So before I finish the rest of this, I want us to go down to the bottom of the page. So I have set A, which is equal to those numbers, set B, which is equal to these numbers, and set C, which is equal to 3 and 5. And then you'll notice down here U. And so U is the universal set. And when we talk about the universal set establishes the world that we're dealing with, okay? So when we think about the world that we're dealing with, it's saying that here is the group of numbers we want to talk about. We can divide those groups up into subsets, which are set A, B, and C. So set A, B, and C are all subsets of the universal set, okay? So if you look at our notation here, again, the universal set is the set containing all elements of all sets under discussion. Then we have the idea of a subset or a proper subset. Now, one of the ways that I distinguish these is you'll notice that subset has a line underneath it. And that, in my brain, triggers the idea of less than or equal to, because a subset is any subset of set of numbers. I'm using the word set a lot. I know that's there's really no way to get around it. So it's a smaller group of numbers from the larger set, but it can even be the set itself. Every set is a subset of itself. So it's the whole idea of equal to, okay? Versus proper subset, they cannot be equal. So a set A is more specifically a proper subset of B if all the elements of A are also elements of B, but A does not equal B. And so again, these are sideways values, or not values, what am I trying to say? They're sideways symbols, okay? And they look like U's that have been turned on their side. Finally, sets are equal if and only if they have all the exact same elements. It doesn't matter if they're written in the same order. So if I had this set, oh geez, see, I told you my symbols get terrible. So if I had 1, 2, 3, that is also equal to the set 3, 1, 2. Because all the elements are the same, right? It's like taking them and putting them in a bag, jumbling it up. 1, 2, 3 is still 2, 1, 3, 2, 3, 1. Like they're still all the same values that are in that bag. And so those two sets are equal if and only if they have the exact same elements. And then the last idea we have is the complement of a set. And you'll see that written as A with apostrophe after it. So A naught. You'll also see it written as A with a little C above it, meaning it's the complement of A. And it's the set of all elements which are in the universal set, but not found in A. I know, a lot of words, okay? So if we go back down to our example here, I've got the universal set. And the 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I think about set A, 0, 1, 2, 3, 4, 5, I can highlight that here within the universal. So this is set A, right? Okay. Then looking at set B is 4, 6, and 8. So 4. Let's make this a little less thick. 4, 6, and 8, right? That's set B. And then finally set C are the numbers 3 and 5. 3 and 5. So you can see how sets A, B, and C are inside the universal set, right? They are in there. And so we're able to discuss how these sets interact with one another. Okay. So for number one, it says the set builder notation X such that X is an even whole number between the numbers 3 and 9. And I want you to tell me which set does it apply to? What set am I describing? Am I describing set A, set B, or set C? Which of those 3 sets would be described by X such that X is an even whole number between 3 and 9? Okay, so if we think about what are even numbers are, they start with 2, 4, 6, 8, 10, 12, 14, blah, blah, blah. And if I'm looking for the numbers that are between 3 and 9, that's going to be those numbers, right? 4, 6, and 8. Well, which of the sets contain the even numbers 4, 6, and 8? Only, and that's going to be set B. So this is a description of set B. All right. I want you to send me a description for set A. Don't worry about using the brackets and all of that. Just send me a description of how I would define set A. How would we define that? So again, you're just sending me a message that just like write out verbally how you would describe it. Don't worry about trying to use the brackets and all that business. Just tell me how you would describe set A. Okay, so a lot of different answers. So seeing numbers that go from 1 to 5, numbers that increase by 1, numbers more than 0, less than 5, all these are really good descriptions. So they're positive numbers, right? We know that. Okay. We know that they start at 0 and end at 5, right? Move from 0 to 5. And so there's a lot of ways we could write this out as words, right? But that's where the notation is helpful, because we can kind of condense that down. And so what we'd want to say is that A is our set. A is equal to the set of, oh gosh, hold on. There we go. X such that X is a whole number and it's greater than or equal to 0, but less than or equal to 5. And so we're able to say a lot just by using the symbols, okay? So again, we're describing this as whole numbers that go from 0 to 5, okay? So using the notation, we would say that set A is the set of elements X, such that X is a whole number and greater than or equal to 0, but less than or equal to 5. Okay, so that establishes our range of values. So again, that is one way that it's helpful to know the mathematical notation, because it allows us to take something that takes a lot of words to say and shrink it down a little bit, right? All right, so we are going to go to the next page. The problems on the next page still talk about these sets. So I'm going to turn the page, but I'm going to copy this over, okay? So we've got, remember, A is equal to the set from 0 to 5. Okay, like I said, my brackets get real bad. B is our set. What is it? What we got here? 4, 6, and 8. C is our set 3 and 5. And then we can't forget the universal, because that's all of these are contained in there. Let's make this a little bit bigger. And the universal of the numbers from 0 to 8. Okay, so number 3 says, what is the value n of NC? What does that mean? Well, remember, n of C, this is saying how many elements are in C, right? That's the question. So if we look at set C, C is equal to the set that contains the numbers 3 and 5, okay? Oh, I gotta wait, my board is taking its sweet time catching up. So let me, so you can see my handwriting before I move forward. So again, set C is the set that contains the elements 3 and 5. So how many elements are those? What would we say that the n of C is equal to?
Would we say 8 or 2?
2, because there's just 2 numbers in there, right?
Okay. Okay.
Yeah. So I have 2 numbers, the numbers 3 and 5. So n of C is equal to 2, because there's 2 elements. All right. So number 5, with that same idea of talking about elements, we have 2 questions. Question number 1 says, is 0 an element of A? In the second part, it says, is 0 an element of B? So remember, we've got sets A and B at the top of our page. Can you guys see them, or are they squished off for you?
Yeah, we can see them.
Okay, so I want you to tell me if you think, is 0 an element of A And then is zero an element of B? So we've got two questions here, question A and question B. So again, when we're answering the question of, is it an element? We say, do we see it in that list? Meaning when I look at set A is the numbers from 0 to 5. Well, since 0 is in that list, we would say that yes, 0 is an element of A, right? But when we look at the list for B, B is the numbers 4, 6, and 8. The number 0 is not listed there. So we would say that 0 is not an element of B. So is 0 an element of B? No. 0 is not an element of B. Okay, so if we look at number 4, it says, is C a proper subset of A? Remember, this is proper subset. So when we think about proper subsets mean that they have to exist completely within the set, but they can't be equal. So if we look at set A, this is A. And C is the numbers 3 and 5. Okay. So here is the number 3 and there's the number 5. Right. So this is set C. So what that tells us is that C is a proper subset of A. But we can't go the other direction. If we looking at the second statement, so again, is C a proper subset of A? Yes. But the second question here, is A a proper subset of C? The answer is no, because A is bigger than C, right? If we look at those two sets, A has more numbers in it than C does. So A cannot be a proper subset of C because everything in A is not contained in C, right? It's bigger, so it can't be. So when you look at number 6, it says name all the proper subsets of B. So B is the set 4, 6, and 8. So when we're naming the proper subsets, your first one should always be the null set. So I'm just going to name it without anything in it, okay? After that, you want to look at your single element sets. So we have the set that contains the number 4. We have the set that contains the number 6. Oops. And we have the set that contains the number 8. You'll notice I'm putting these within their own brackets. If I'm writing a set of values, I have to put them in the brackets, okay? After that, we can look at the 2 element sets. And the 2 element sets, we can have the numbers 4 and 6. We can have the numbers 4 and 8. And then finally, we can't forget the combination of 6 and 8. Oops, I've got to be careful. These start to look like 3s if I'm not paying attention. There we go. And so I can't relist the set like 6, 4, because remember we talked about the set 4-6 is the same as the set 6-4. You don't want to repeat them by changing the order, okay? But because we're looking at proper subsets, we can't list the whole set itself again. If we're just saying subsets, then yes, but remember, proper subset, they must be less than B. So I want you to look at number 7 and number 8, okay? So number 7 says, is A not a proper subset of B a true statement? So is A not a proper subset of B? That's what, again, that's what that statement is trying to say. So is that true? And then in number 8, it says, is the null set a proper subset of C a true statement? Okay, so send me your 2 answers. Answer for number 7, answer for number 8. Let me know what you think. Okay. So in number 7, A is not a proper subset of B. So if we think about comparing A and B, so A and B from the comparison alone of how many elements are in the two sets. Okay. Oh my God, I cannot draw this symbol right now. Okay, so think about the two sets, right? A has what, 6 elements in it, and B has 3 elements. And if we're saying that A is a proper subset of B, that means that even by size, A has to be smaller than B. But because A is not smaller than B, there is no way it could be a proper subset. Okay, so is A not a proper subset of B a true statement? Yes, it is not. Does not fit in there, right? As for number 8, is the null set a proper subset of C a true statement? And that is yes, because as I said in number 6, the null set is a subset, and more importantly, a proper subset of every set. The idea that, like, if you have this value, you can have nothing in there, right? So it's always going to be a subset, right? So number 9, it says which elements are found in C complement. Okay, so which elements are in C complement, which, remember, C complement means not C. Okay, so in order to answer this question, we have to look at our universal set. And our universal set, you'll sometimes see the U with the universal set written with serif, meaning it's going to have like these little like lines at the top. And so our universal set is the numbers from 0 to 8, right? If we see at the top of the page. So in order to identify the complement of C, we have to look at the universal set that it's a part of, which is the set that I have listed. And I'm going to highlight, like I did before, what are the elements of C. So the elements of C are the numbers 3, 5, right? We have that in the upper section of our window. So again, if I highlight 3 and 5, okay, those numbers are in C, so they can't be in the complement of C. So if we write the complement of C, we're going to say that C complement is equal to everything but C. So you'll notice I skipped number 3. So I went 0, 1, 2. Can't have 3 because 3 is in C. Then 4, I have to skip 5. And then I'll do 6, 7, and 8. Okay. So again, so C complement, that is the set because those are the numbers that are not in C. Okay, so we always have to have that universal set that we're comparing everything to, so that we can take stuff away. So number 10 says, is 5 not an element of B complement a true statement? So before we can even answer that, here's what I want you to do. Identify B complement. So I want you to think about what I did in number 9 to identify C complement. Think about what the universal set is up at the top, what is set B, and I want you to send me your idea of what B complement is. What is in B complement? So what's not in B? So if we look at B complement, here is my universal, okay? And we know that B is equal to the numbers 4, 6, and 8, okay? So first of all, in order for an element to be not in a complement, it needed to be in the original set, okay? So because 5 isn't in the original set, it's going to automatically be in the complement, okay? So this statement is not a true statement. But again, how do we know it's not a true statement? Well, if we highlight our elements of B, okay, so we have 4, 6, and 8. There's B. That means that B complement, or not B, is everything that I did not highlight. So everything that I did not highlight is 0, 1, 2, 3, 5, and 7. So because the number 5 is right here, and it is an element of B complement, that is not a true statement, because remember, the element part with the line through it means not an element, and it is clearly an element. So that makes number 10 not a true statement, okay? I know these are confusing, so I always draw a picture. Always draw out what you're trying, or write out, right? Like write that universal, highlight what you need to remove, then do your next one. And that's going to be really helpful now that we go down to talking about operations with sets, okay? So we have two operations that can happen between sets. We can have the intersection, which is where two sets overlap. And when I say overlap, it's the set of all elements that are common to both A and B. So again, it's where A and B overlap. Okay, so if you think about an intersection, right, of a road. If we have road A going this way and road B going that way, this stuff right here, that spot, oh wait, hold on, my board's taking forever. That spot right there that I highlighted in orange, that's the intersection, because that is where the two roads intersect. And the same is going to be true when we're looking at sets. Intersections are going to be smaller than the two sets themselves, versus the idea of a union. The union of two sets becomes bigger. Okay, if you think about a union of people is a group of people. Okay, and we think about combining this is combining two sets together to create a larger set that contains both A and B. Okay, and then we have the last idea, which is disjoint sets. And these are sets which have no elements in common. A and B are considered disjoint if and only if their intersection is the null set. So two disjoint sets have no intersection. Meaning they do not overlap. So if we think about in our, we think about the set of cats and the set of dogs. Cats and dogs do not have any species that is common to both of them, right? There's no catogs, as I say. So those are two disjoint sets. Cats and dogs are completely separate. They do not overlap. There is nothing that is common to both. But if we were to think of the sets of lions and tigers, there isn't actually a liger. A liger is a real thing. It's when a lion and a tiger mate, and they produce a liger. And so that would be considered the overlap, or where those two sets would intersect. Okay. So when we're looking at applying these, we're going to always be going back to the concept of what that universal set is. So we have three new sets, set A, B, and C, and these are all subsets of this universal set that I have listed on the end. And so the first one is A union B, okay? Right, that's what that symbolism means. So we want to union them together, and when we union them together, it means that we're grouping them together in a bigger group. So if we think about set A, we've got the numbers 0, 1, 2, 3, 4, and 5, right? But now I want to add B in there. And if I look at B, well, I've already listed the numbers 4 and 5, so I don't need to list those again. But I can continue on with what's in that list that is not, I haven't already listed. And so the numbers 6 and 8 are remaining. And so that is our union of those two sets. We think about highlighting. Here is set A. And then here is set B. So we can see how those two sets together make the union. Now, for number 2, I'm saying, what's the intersection? Right? Where do those two sets intersect? Meaning, where does A overlap with B? So I want you to think about what I have written already on here for number 1. And I want you to send me what you think would be the intersection for A and B. What numbers would be the intersection? So we can even see it in my highlighting, right? And that's why I really like to draw pictures and use colors for this, okay? So I'm looking at the intersection. I'm looking at where do these two sets overlap? And I can see it right here in my highlighting, right? Because green and pink overlap to make this weird gray color. And so they overlap at the numbers 4 and 5. So A intersects B at the numbers 4 and 5. So that is the intersect of those two sets. So, all right, we're going to go to the next page. And we want to bring these sets with us. So I'm going to flip the page and write the sets down again so that we have them for referencing for these things. So again, A is equal to 0 through 5. So 0, 1, 2, 3, 4, 5. B is equal to 4, 5, 6, 8. Oops. C is equal to 3, 5, and 7. And then we have our universal set, which is the numbers from 0 to 8. All right. So number 3 says A complement union B. So when I say A complement union B, and my board is taking forever, let me wait for this handwriting to finish. So that is the union of those two sets. And you're probably going to be saying to me like, but wait, Aaron, we don't have a complement. We have A, B, C, and the universal. What that means is that before we can find this union, we need to first find a complement. So if we think about our order that we need to do these things in, step 1 is find a complement. So I want you to go ahead and identify a complement and then send me your answer in a direct message. So remember, when we're finding the complement, we start with the universal. So if we have our universal set, okay, and if we highlight what is A is the numbers from 0 to 5, right? So that means what's left that's not highlighted is going to be the complement, okay? So what's left here are the numbers 6, 7, and 8, because those are not in A. Therefore, A complement is 6, 7, 8, okay? So we want to union that with B. So A complement union B. And what that means is we want to add them together. We're going to combine them into a bigger group. So remember, set B is 4, 5, 6, and 8. So we're going to take 4, 5, 6, and 8, right? That's all the B stuff. And then what is the piece we're missing? We're missing 7 in order to put those together, right? We're putting them together. We're putting them in a bigger group. We don't want to relist numbers, okay? If it's already in 1, we don't need to list it again. So A complement was 6, 7, and 8. B was 4, 5, 6, and 8. So when I join them together, I needed to bring that 7 in. Now, if this feels weird to have them listed out of numerical order, that's fine. You can just switch it up, right? So 4, 5, 6, 7, 8 would make A complement union B. So these kind of follow order of operations in terms of, if we look at number 4, it says A complement intersect B complement. Okay, so what do you think we need to find first there?
The complements of each.
Yeah, so when we're finding, so it's saying A complement intersect B complement, right? So in order to find the intersect, we have to even know what those complements are. So step 1 is find a complement, and step 2 would be to find B complement, and then step 3 is identify where they overlap, right? We're identifying what values are in both of those, okay? So I want you to identify what A complement is, what B complement is, and then tell me where those two overlap. We already know A complement from number 3, right? Okay, so A complement, we already know, is 6, 7, and 8. Okay. B complement is everything that's in the universal but not in B. So B is 4, 5, 6, and 8. So B complement is going to be 0, 1, 2, 3. Can't do 4, 5, 6 because those are already in B. We can list 7, but we can't list 8 because it's in B. And then if we're looking at for where they overlap, again, we're just saying what value is common to both lists. Well, the number is 7, and the number 7 is in both of those lists. Therefore, the final answer of A complement intersect B complement is the set with just the number 7 in it. That is our final answer. So like I said, these do follow order of operations. If I look at number 5, it's got A union B, which is in parentheses, and then intersect C. So just like we would with order of operations, we would want to find the union first, identify that group, and then figure out where that union intersected with C. So if we think about our steps, 1 is going to be find A union B. And then number 2, step 2 is identify where A union B overlaps with C. So that's gonna be number 5. I know we're running low on time because I want to talk about number 6 too. For number 6, and we'll check these values for number 5 and number 6 when we come back next week. Number 6, it says C intersect B complement. So what that's telling us is that it's the complement of that intersection. So again, 1 would be find where C overlaps with B, right? That's what we're identifying first, that intersection. And then 2, identify the complement of that set. Okay, so I'm gonna let you 5 and 6 on your own. We'll talk about them next week because I know we're right at time. speaking of next week, as I said before, we've got, you have test 2 due on Tuesday. So if you need a proctor and you've not set it up, please do it today. Like we have got to get that done. So that you've got that time established. You've talked to Grace, all the communication that needs to happen has happened. Because I don't want you getting into a pressure situation in the last hour and suddenly like you can't take your exam. So, again, test 2 is due on Tuesday. And then when we come back next week on Tuesday, we will get into 3B, and hopefully a little bit of 3C. So, any questions for me before I let you go?
Were you able to check my written work on that quiz or no?
I have not had a chance to yet, Luke, but I will get it done today, I promise.
Okay, yeah, I was just curious. Thank you.
Yep, thank you. Other questions? Okay, well, I hope everybody has a great day and a great weekend, and I will see you all on Tuesday. In the meantime, email me if you have questions, okay? All right, bye everyone.
Thanks, Aaron.
Bye.